Welcome, part 9. So, as always, let me quickly check that everything is up and running. Looks good. So, yes, last time we left off with our first sprint, and there was mixed bag to say the least. But I can report that we fixed the issue. There was quite a lot of troubleshooting. That took me busy the weekend, to be honest. I think we fixed it finally on Tuesday or Wednesday. So it was a lot of time effort, but in the end, everything resolved. Let me quickly show you. So I printed a couple of cubes, as you can see. Uh, one or two. Also some deliberately scaled ones, just to see what was causing the issue. Hi there, Rush. So, just to quickly check what we left off with. So, just zoom in here. So this is the cube we printed last stream. You can see there's this little gold mark from the first print and the little one I put there. And I mean, it's white. I'm sure I've used maybe a different color filament, but you can see very clearly there's lots of ringing or some artifacts. We clearly have very bad Z stepping. Hi there, Mr. DSI. Mr. the DSI. It's not a nice print, but most notably you can see it's not square. I actually have my little right angle thing over there, so I can't really tell you. But maybe if I put it here, you can't really see it. But yeah, this is not square. It's tilted to one side. So it's just tilted towards here. So it's not a cube. Which tilts, you see it in two directions. So it tilts a little bit like this direction over here, but also when I rotate it, it still tilts over there. Yeah, you can also see there's just a lot of bad surface artifacts going on. So it's not a nice cube. So I was a bit confused what was going on here because I mean there were a couple of things going on. The first thing I did is I just went through the machine and just touched everything, wiggled on all the parts, maybe something was loose. Just double checked with my machine is square, that everything is square, just the frame is square. And the first issue I then discovered was here in the Z drives. So there are the little belt loops here. I'm not sure if we can get any lower. So these little belt loops here, I noticed were really loose. So now you can see they're quite stiff. And if I move here the Z axis, you can see there's direct movement. Let me see if I can rotate it a bit, maybe. So if I wiggle here on the gantry, you see the movement is completely synchronized between the two wheels. Initially, when I was looking at the machine after our last stream, that was not the case. There was a lot of slop here. So basically, you could press in the belt here with your finger quite a bit. And when you wiggled on the gantry, then you could see that the belt was deforming here. So basically it had backlash in the end. There had to be a certain distance of movement on the gantry before the movement on the gantry translated to the actual stepper, which then in return means when the stepper moves, there's a certain amount of distance it has to move until it properly translates into the gantry, which is really not ideal, especially if you have small Z movements. If you would print with Z-Hop, which I don't do, but I think the print actually had Z-Hop enabled. So Z-Hop wouldn't be ideal, but also if you have a bad mesh on, that moves up and down the entire time. So it's not ideal. You obviously want precise Z movement. Hi there, Steve. Welcome. So this was issue 1. I solved that by replacing these little levers. So these are the stock ones. And I found on Printables a version. I posted a link in the Discord. You can find the Discord link in the description. All the mods and parts I have outside of the normal 2.4, you will find in the Discord. I also have the entire Orca slicer project with all the sliced parts also there. Um, so I printed new ones of these, and they are on this side here ever so slightly wider. So as you tension them here, it basically pushes the motor a little bit further out and puts more tension on the belt here. I don't know why I need that. Somebody made that part, so I'm not the only one needing that. And a lot of people on that printables commented that they had inconsistent tap results, which again, like very small Z movements. And that's fixed it for them. For me, like this just fixed the print. So I think, so if we look at two cubes, so I think these two cubes are kind of like representative. So this one was the one we did in the stream. And this one is, you can still see it's crooked, like it's not straight, like they are identically tilted. But this one has like way less weird artifacts from Z. So the Z movement was fixed with this one. I think on this side you see it better. You see here like all these like weird lines, they're mostly gone on this one. But yeah, it's still crooked. Maybe I can show you here because this is square. So you can see that the cube doesn't touch here on the top. So it touches on the bottom, but not on the top. I actually think it leans here. This is the leaning direction. So you see there's quite a gap on top. And this one has, I think, even a bigger gap a bit, but yeah, still there's a gap here. So that was problem one. Easy enough to fix. Problem two is the tilt, obviously, right? Like we want our printers to print straight. And that's where it got interesting. Because I was like printing a lot of cubes. I was just trying out different things, you know, like printing in the center of the bed, printing in the corner of the bed, front corner of the bed. This is not all I printed. It's a subset of what I printed. And I was like, trying out, like, for example, hey, what happens if I print the Voron cubes a little bit like stretched out? Because then you have like more like extrusion, maybe that changes a bit, maybe something you can see. Then I was trying very simple cubes, which actually was very interesting. Like this was printed somewhere in the middle of all of this. And this is where like I kind of lost all hope in this printer, because this is square. So it printed this perfectly straight. And then afterwards, basically, it printed like a cube like this that is crooked. Like, how can I print this straight, but this crooked? And then I printed this, which is like a 15 millimeter or 150 millimeter tall cylinder. It's a bit hard to show now, but trust me, this is completely straight over 150 millimeters. So how can a printer produce this crooked and this straight? And I was like, what is going on here? Because like if it would be a mechanical issue, I would expect everything to be like crooked in the same way. Like if the frame isn't square, I would expect all parts to have the same crookedness to them. So that was not it. At some point, and big shout out to Mr. the DSI and Steve who held my hand and like suggested a lot of things during the entire weekend. At some point we were like, maybe it's a slicer issue. So I used also like Prusa slice for a couple of these cubes. Don't ask me which ones. Also didn't help. I checked also if the slicer file had the tilt already in, because you know, like if this is straight and this is crooked, like maybe it's a slicer. But it also wasn't it. And then eventually, Mr. the DSI was checking the Clipper Discord again, and not the Clipper community. And Steve already floated the idea at some point on Sunday whether it's like a Clipper issue. And I actually also searched on the Clipper community, but didn't find anything. But this one was kind of flying under the radar. And this is very interesting because it's exactly the same mainboard, exactly the same tooling board, exactly the same printer. It's a different, it's a Pi CM4 of CB1, but it's, besides that, it's identical. And the description matches very well what I see here. So they already had the machine running. They upgraded Clipper to the version is from 33 to 78, and then they saw their prints shift over time. So notice my prints began drifting gradually to the side on the x-axis to the point where they were leaning a few millimeters to the side after 10 millimeter height or so. So this is not layer shift is regular, but a gradual change. And this is exactly what I had here with these boron cubes. And if you follow this like whole discussion, it's really cool from the Clipper community. Like they immediately like looked at this and like investigated and looked at the electronics and like really did a deep dive, which is really cool. Like very nice to see. And eventually found out there's a bad Clipper commit. I don't know which version exactly, but it was like somewhere in the 60s. I think it was in the end. Somewhere it says like which exact Clipper update it was. But yeah, I had 0.1387. So I was in the affected version range basically when the bug was introduced and before it was fixed. Because we installed we flashed the boards 2 weeks ago. So it was exactly that on when Clipper had this bug. So yeah. And this seemingly only affected main boards that have the STM32 chip, which is the M8P has exactly that chip. So that's not all the Clipper with these versions have that bug, but some. Yeah, so I was going here at the end saying thank you. But yeah, that was that. Like I updated Clipper. I literally did nothing but update Clipper. And we went from this cube that is obviously not straight to this cube, which is straight. So it was nothing else but a Clipper bug. And as soon as I installed the Clipper firmware, or like the Clipper update, so I basically had to reflash the M8P. That was the only caveat there. Everything just worked. Like, I actually don't have any prints here that I did after the fix, I think. This Benchy definitely was before. Yeah, this one I think is a Benchy I did after the Clipper update. So it's a fine Benchy. Like there are some cooling issues here, which to be expected, to be honest, with the fan that we have included here. It's not the best fan, but it's a Benchy. Like it doesn't have any major defects. It has the hull line, which is fine. Yeah, it has a hull line and the cooling issues, but it's basically it. Like this is a okay Benchy for like a printer that just was assembled, like without a lot of tuning being done. So yeah, basically we were just extremely unlucky to have a bad Clipper update, which basically drives home the point I have always. If you don't need to, don't update your Clipper. Like if it runs, it runs. Unless there's something broken or you really want to have like some new features they published, just keep running what you're running. It's stable. Yeah, so that was basically like 3 days of troubleshooting. And in the end, it was something super stupid. So let me actually quickly get rid of all my Voron cubes here. Then we have a bit more space. I don't think we need those anymore. And as a small side note, before we dive into building stuff, actually, so I did run some more tuning on the machine, and I did like this is the V6 Hotend. That's like the standard for the kit. And I did like a flow rate or like a max flow test. Yeah, not much to see. So basically, it kept out at around 12 millimeter cubed per second. So it's definitely the weak point of this kit. And I think it's definitely worth like upgrading the Hotend, which is coincidentally something we will do today. So, I mean, you can either go with one of the upgrade options they have. I think it's the, I don't even know which one, but like they're like better Hotend. So just go with one of these. You need to update it anyways because it's really like the entire bottleneck of this machine. So today we are going to do panels. That was on the to-do list. My plan now is basically to put the panels on today. and to change the hot end. As I mentioned, we're going to upgrade that. And that basically will make this machine ready to print ABS. With the V6 that's currently in, I'm a bit on the edge whether I want to print ABS or not, because it's not a full metal hot end, so that might release some nasty fumes. So I have a replacement hot end here, so I'll just swap it in now. And then the machine is ready for ABS, and I will print all the skirts next week. And then basically in 7 days, we can install the skirts, the bottom panel, and ready, like finish up the machine basically. Not a high temp hot end. No, it's definitely not. I think if you for PLA, it's fine. It's just like it really limits the printer in terms of speed because the flow rate is just so low. Like this is like even though I run it now with the stock configuration, so 0.8 amps on the steppers, it's really fast. Like it's really fast. I think it caps out for me I did some speed tests. I think it caps out at like 15K acceleration at 700 millimeters per second. That's kind of like where it starts losing steps and stuff. But if you, yeah, like even that is really fast. Like it's a big machine, so you need definitely the speed. But yeah, it's fast, and the hot end just completely limits the entire thing. I already ran like an 8-hour print job on that. I printed some windowsill holders, I guess. There was an 8-hour print job, and that worked out really well. Like it took 8 hours because the hot end kind of limits everything, but they look great. They work. They're very stable. So I'm very happy with that already. Okay, enough talk. So that was kind of like the backstory, how we transitioned from having like horrible prints to quite good prints actually. Let's check what we do today. I'm trying to not fall over. So, panels and some related stuff. So this is what basically is left of the kit, more or less. We still have the clipper screen and fans and stuff like that, but this is more or less the big parts of the kit that are left. The kit comes with foam tape. This is the 1mm foam tape, and we have two rolls of like 3mm foam tape. This one kind of like fell apart, but it will still work. The bottom panel we will not install. We don't have skirts, so it kind of doesn't really make sense. But all the other panels we will install right now, basically. There's also left this little light bar, which I don't find very attractive, to be honest. But we will install it for the beginning. It will, yeah, functionally it will be fine. So that's on the list. We also have the exhaust parts, which I will install for now. And it also comes with this little like injection molded spool holder that will fit once the panel is on. And where did I put it? Yes. So hot end wise, we will upgrade to this little guy here. This is a Triangle Lab. Now I need to get it right. TZE3 2.0. It's a relatively cheap hot end, so this is like 20 euros. But it should be very capable. There was a recommendation from Ravenkeeper, who's also on the stream sometimes, and I'll just give it a shot. Like I printed the mounting adapter for it, for the stealth burner. So this should be more or less a drop-in replacement. The only thing we need to do, we might need to recrimp the thermistor cable. I need to double check. I think this is the bigger one. We need a smaller one. It might lengthwise just fit. And this one is the, oh no, this is the thermistor. So this lengthwise will be fine, but we might need to recrimp it. And this one is the actual hot end. So we need to not extend that. I think I will just like make a cable to plug in and then like crimp the proper connector on it. Yes, so that's that. And there's one more thing. I kind of messed up the panel clips. Printed the wrong panel clips, which I mostly fixed. Except for one print. So let me quickly grab the current print and start the last print for the panel clips. 1 second. It's just-in-time production. Here we go. Okay. Yeah, to be honest, let's just start with the panel clips. I think until we need them, the new parts will be ready. So, yeah, as you can see, it's quite a bit of parts. I did print the standard panel clips because I know I will work quite a bit on this machine, especially in the beginning. And the normal panel clips you have to unscrew every single time you work on the machine. So what I will use, I'm still not sure. I also always got the completes to here. 2.4 magnetic panel clips. These. So these are magnetic panel clips, which in theory looks really nice. I actually, you can see it back there. I tried one panel and they work. I kind of burned my fingers with magnetic panel clips on V0. And this is basically what we are going to build now. So I think we need to assemble quite a bunch of these. And yeah, let's get started. Sorry for the long introduction talk. Let's quickly check. So we have 6 of these center panel clips. Then now we need to pay attention because I have 2 different heights of these. I first printed panel clips for the 1mm foam, but we're gonna use the 3mm foam on the side. So let me just group them. So this is 1, 2, 3. This one is 1 I already did. This is, yeah, 4. So these are the left and right panel. For the top panel, we're going to use the thinner foam. That will be fine there. So we need 4 of the thinner ones. And then 2 of the thinner flat ones. And then we have these cover pieces. So this is also for one side. Two sides. This is the centerpiece covers. Centerpiece covers. Corner, centerpiece. Another centerpiece. And another centerpiece. There should be one more corner, and then we have it all. Here it is. Okay, so this is for the top. Let me move that to the side for now. And we will just start with one of the side panels. Also have tons of magnets. Let me just grab a few. Let me quickly check because I already inserted a couple of magnets. I would just like make sure we have the same orientation on everything because otherwise it will be quite painful. And then how I learned to insert the magnets here. Oh, that went well. Let's do, I think we have to do them one by one. Oh, this one broke. Sad. Let's quickly check again. So this one, so let's do just one. They're very stiff to insert. So I just have this aluminum piece here. It's kind of okay to press it in with this. but it doesn't go fully in. And what works really well is if I just take this and just use one of these wood working quick release clamps, and then you can just quick clamp them in there. And then they're in, and they're actually so well in that you don't really need glue. Like, these are not coming out. So, I had the thinner ones I had prepared. That's, okay. So I think we just do one side of these panels for now. Because it really takes like a second to press all the magnets in. I don't think this is like super interesting to watch. Hi there, Alex. Sorry, I missed your message. One of the best upgrades I done on my 2.4 was the clicky clacky door mod. Yes, that's also on my to-do list. For now, I have the standard door hinges printed. But yeah, I'll definitely upgrade that most likely down the road. You know, so yeah, I already noticed that like the printed hinges that are like the standard for the 2.4, they don't feel really nice. Like they don't rotate very well. So it's yeah, just like yeah, feels as you say, it doesn't feel premium. I think that's a good word. So these are the corners. So basically what we're going to do is like on the sides, you notice I only have 3 of these middle pieces here, which are very nicely magnetic. On the top, we're going to use a latch. So basically I have the magnets on 3 sides, and on the top basically just as a like security in a certain sense, we have like a latch, just to hold everything securely in place. And I think, to be honest, the magnets are plenty enough to keep everything in place. It's just like for my peace of mind, basically, that I added the latch on the top. Here we go. This one. This doesn't want to cooperate. Okay, so these are the pieces we need for the clips here. By the magic of preparation, I have one panel ready, basically. The only problem, that's what I mentioned, I kind of screwed up here a bit because I applied the 1mm foam tape on the edge here, so we quickly have to redo that. And I hope they come off nice. I just noticed before the stream that I used the wrong foam tape. And it doesn't come off nice, at which point I think we will just leave this for now, and I might have to peel this after the stream. So I think we just leave this on for now, because it's not really like nice to peel off. But let's just apply the foam tape on like another panel. But then we have to quickly do the corners for that panel as well. So let's quickly finish these. And so how this works basically, you see there are like 2 screw holes left, and we use a M3 by 12 screw. So the screw head sticks out, and the screw head basically goes into this like socket here, and that holds the panel in place like vertically basically, just to make sure everything's secure. So the magnets only hold it shut, but they don't have to hold it like preventing from falling down. So, and ask me how I know. You need to pay attention which of the magnets, which holes you use the magnet for, because they're almost the same size. And we need to pay attention that it's the opposite direction, of course. So not the outer ones, but the inner holes are for the magnets. Right. So it's this direction. It's this direction. Go on. Third attempt is the charm. Yes. And then we now can copy the orientation from here. That's one. This way. Here you go. And maybe while I complete this, did anyone else have like a bad Clipper update before? I wonder if I just was like super unlucky now, or if somebody else had issues before. The only other bad update I had before was a Linux update actually, where Linux broke Alice USB, like the command that Clipper uses to identify the boards. That was broken after the Linux update. And then obviously nothing worked anymore because Clipper didn't find the main board anymore. I was like very early on in my Clipper experience. That was quite a painful lesson. Just make sure we are still in the right orientation here. Oh, this magnet is not in properly. I know there's like dedicated pliers to press, like not exactly to press magnets into place, but in general for these like press fit stuff. And I always wonder if I should buy something like that, because it seems like incredibly useful. I mean, this kind of works, but it's a bit unwieldy, I would say. Okay, last one. Hey. I love magnets. It's always fun. Okay. So this is one panel. Let's try it out. Park these here. I think it doesn't really matter which side we start with. I've only done one Clipper update before. I tend to hold off because last Clipper upgrade was from 12 to 13 and I had to flash the firmware on the MCU. It's not too bad though. Yeah, that's the thing, like, technically Clipper updates can be quite laborious. If you have to reflash all the MCUs, like, it can get out of hand quite quickly, depending on how many MCUs you have. But yeah, if you have Catapult, it's actually quite easy. But the main problem I have, like, I don't do it too often. And then if you don't do something like regularly, you always forget how to do it. Okay, so, oh yeah, that was the one side. I tried the panel clips here, and these are the ones that are not tall enough. Let me just get rid of them quickly. I luckily tried before the stream and realized that I printed the wrong ones. So basically, I realized like 1.5 hours before the stream, and I still had enough time to quickly print a fresh batch of these. Oh, this one's actually already tall. So this one is with my test foam. Yeah, the foam actually doesn't. So if it, I pulled it off immediately after I taped it before, and it was fine. But seemingly, if it sets for a second, it gets a bit iffy to remove. Okay, so we still have our big hardware bag from the kit. Just put it over here. And let's actually quickly peek into the manual. Because the manual technically is relevant for us again. Like, we kind of diverted from the manual for the electronics a bit, because like we don't have the same electronics as the manual suggests we have. For the panel, obviously, we now also have different panel clips, but the mounting mechanism is exactly the same as the stock panels. So if you have the stock panels, you can just follow along. We are very deep into this manual. I always forget how long these are. Yeah, so this is the skirt section, which we skip basically for now. And we pick up at the panels, which is here. So the back panel, yeah, we now started the side panel, so let's do the side panel first. So for the side panel, we basically have the 3mm foam tape. We're gonna apply it in a second. Let's first get these things mounted. And then we use M3 hammer nuts and M3 by 12. Let me get the M3 by 12. Yeah, this is this bag here. I just spill a couple here. So please get only the ones we need for now. Like these are all these like top covers, and these are the one we need. So basically, I mean, it's that simple. We take 2 screws, punch them through if you want to. Oh no. Oh, we screw them through. And put one of the hammer nuts on the other side. I noticed the hammer nuts in this kit are a bit weird. Normally I know, or like I expect from hammer nuts that they, like if I tighten the screw now, I expect the hammer nut to rotate itself into position. Yeah, it's not really sliding through. So I expect the hammer nut to rotate itself into position, but that is not really happening with these. And now it's kind of doing it. Not quite. So they always need a bit of help to rotate themselves into position, which is, yeah, a bit iffy. I mean, now this also doesn't help that the screw doesn't slide fully through. I fear we need to drill those out again. I don't. I mean, we had this issue before, and I did not update my printer, or like I didn't check what on the V0 makes these a little bit iffy. I think if you just maybe punch it through, that should help. Drill out the holes. Yeah, I think that's the way to go. I think that's the way we have to go. Sure, if we can do it like this. Otherwise, I quickly get a drill. I think this seems to work well. Just quickly punch through with the screwdriver. It's not like they're like off by a lot. Yeah, and this is not what I mentioned. Like, so usually this hammer nut should rotate itself in place, but it doesn't like to do that for some reason. So I always use like tweezers to rotate them manually in place, which is a bit of a bummer. It takes away like a lot of the comfort. Okay, so it's one corner. Hi there, Ravenkeeper. Welcome. The nut need to be at the bottom of the T-slot to rotate. Yeah, I think they're pretty much on the bottom because I don't screw in like a lot. So the screw's not peeking out on the other side or something. Right? So basically what I do is like I take it, I just put the T-nut on, so it's like definitely has the ability to go all the way to the bottom. And then I put it in the extrusion. And I mean I even press down on the screw, but like they don't rotate. I don't ask me why or how. It's also the first time I'm using like the hammerhead T-nuts, but these are they just don't do it. I don't know why. Yeah, that makes it a little bit like iffy to use them. I also see here already this one is not where it's supposed to be. So let me quickly, because like if I loosen this now completely, the nut is all the way on the bottom of the extrusion. But if I rotate it, like it doesn't, like if I screw the screw, like it doesn't feel like rotating itself into the proper position. It's really weird. I'm not quite sure if there's some problem with the hammerhead T-nuts or something. I used an electric screwdriver to drive it right and tight and loose until the hammer nut locked itself into place. Oh, so you just like did it up and down basically. I guess it also works. Okay. It's a bit like if they have too much friction or something to rotate in this slot. Because I really just like it just pulls up like straight. Like it doesn't do any rotating. Okay, so these are four. Uh, let's actually also install the three sides. So we have one here, one on the bottom, and one here. These are just basically to clamp it down a bit so that we don't get like weird vibrations. Oh, so here, this one is perfect. Not sure what's up with the corners. But my little trick doesn't work with these. Because I can't, I mean, I can technically rotate them here as well. Can I? Oh, it's wrong in the, it's faced this way. Ah, now this one rotated. Perfect. Oh, but this one, oh, for this one, actually now I have a little mark here in the screw. So maybe we need to use shorter screws for these. Let me quickly try a M38 for this one. No, it's definitely no go. M3A basically peaks out. Let's see about M310. We don't need many. M36. No, I don't think we have any M310s here. Then let's skip these. I can apply them later. But yeah, you see here, there's basically like a little mark in the extrusion now. And it wasn't fully tight. So the screw just like bottoms out basically. So they're like a little bit too long, which is odd because I would expect this to be exactly identical. Although the screw does sit a little bit lower with these. So maybe these are just okay. But nevertheless, let's quickly skip them. Let's just put a panel in. I'm actually not sure if the panel on the top has the same or different dimensions, but this one fits, so we'll run with this one. So this sits nice and fine. Later we might need to adjust them a little bit. Just screw and don't stop. It will rotate the correct height in the slot. I mean, I can try again. I can try like a driver. Needs to be screwed not too slow. Yeah, I don't know. um, I didn't announce the peel, but we have a peel. Luckily, that comes off very, very easily. Okay, let me quickly check where this tape starts. I don't remember who, but like I read somewhere that they were really unhappy with the foam tape that came with the kit, with the Formbot kit. I don't know, like I mean it's foam. It's okay, I think. The only thing, the backing paper is really finicky. Like sometimes it rips. I have these scissors here. Okay. I'll just drop it on the floor and worry about it later. Yeah, it's like you see here, like it starts ripping a little bit, and it's like really annoying to keep going. Because then you also have the yellow bits later on the printer. So on the side panels here, we use the 3mm foam tape, and the manual helpfully states that this is the case, that the gantry here has a little bit of like distance to the panel and doesn't touch that the gantry doesn't touch the panel, which I guess definitely makes sense. Okay. Quickly get my tweezers out here. Let's quickly grab a knife for this one. Let's just rotate that. Exact same thing again. Yeah, like this is a bit annoying. Like this does not. Like as soon as it starts ripping, it obviously rips more. And then I definitely don't want this yellow stuff. Because like what we are taping now here down, like this is the inside, right? Actually, I also wonder if it would be also a solution to not tape the foam to the panel itself, but to the extrusion. I mean, then you don't have to worry about these little bits of yellow tape here. But let's do it like the manual suggests. think now I have a bit of, no, there's no backing tape on the back. Hi there, Jigger Megafold. Sorry for butchering your name. Has it exploded yet? No, it didn't explode yet. It actually prints quite fine. I already had like an 8-hour print job running on it with PLA on the weekend, not on the weekend, like yesterday. Yesterday. And it prints pretty fine. Like after we sorted the issue that every print was like tilted, or like every how to say that is every print that was more complex than a simple cylinder or a simple cube was tilted to X minus and Y minus. And after we sorted that, everything worked out perfectly. So it's printing very, very decently. Still needs to, you know, go through like a fair bit of tuning, I guess, to like sort out like small issues here and there. But yeah, like the big issue of the tilted prints kept me busy. And then I kind of like run out of steam, to be honest, to start fine-tuning everything. And then the other thing is, we're also going to switch to Hotend in a second, so I figured it doesn't make sense to like tune a lot with a temporary Hotend, so to say. Okay, so this is basically how I had that. So what I will do now is just like loosen the screws a bit and adjust the position slightly. I think this one is fine, but here there's a little bit of a gap. Just that sits kind of like snug, but also not too snug, of course. Mostly that the clips are straight. This one definitely was crooked. It's very annoying to have the screw like next to the magnet because like your screwdriver is kind of like attracted by the magnet, of course. Okay, so this sits and fits. A little bit of wiggle, which is good. Then we have, so we skipped the center ones. Let me quickly remove those from the equation here. So now basically we have these corner clips here. And I'm not quite sure how this is intended by the designer of these clips, because technically this works. Like the panel is now paneled. Like this is fixed. Mine is that like in the middle, like we need like some extra. But this is fine. Like you can just have it like this. The only downside I see with this now, like to remove the panel, you basically have to remove 1, 2, 3, 4, 5, like 7 clips. I'm not going to do that. So what I did on the one in the back here that you can't see because behind the printer, is I used a little bit of VHB tape to just like glue these down. I'm actually wondering if you can like use just like instant like super glue, but for now let's just go with VHB because it's removable in case we change our mind. I always hate it when it just works. No fun when to find out where it failed. Well, I totally get you. Like I enjoy this like detective work of like tracing issues. Like I really enjoy it. But for me, there's like a cutoff point, and like from this cutoff point, I hate it. Like I like, how to say that. I like challenges if they are not too hard. And the issue with the tilted prints, that was just deadly annoying at some point. Like, you know, like if you say, I spent on, I'm not quite sure how much I spent, but I think like roughly maybe like 12 to 15 hours. And it was just like, it didn't make sense. Like all the things I uncovered in my quest did not add up to something. So basically, I mean, I know trash the prints, but all the prints were tilted, and not all the prints were tilted. Voron cubes were tilted, like the Voron test cube was tilted. But if I printed a cylinder or a simple like cube, like without any Voron test stuff, they were straight. So it was only specific prints that were tilted. So I mean that kind of rules out mechanical issues because like, if it's mechanical, right, like it's everything is tilted the same way because the frame isn't square, everything is tilted. Need to be a little careful when we rotate this here to not kick stuff off the table. So in retrospect, it was obvious that it was a software mistake. It took quite a while. Like I was just doing like a lot of prints, like printing on the center of the bed, printing in the corner of the bed, printing in the other corner of the bed, just to see what was going on. The only issue I obviously found, or like I found very quickly because it was obvious, was the Z belts were not tightened enough, but that was not the main issue why it was tilted. The other thing I found out is that Z3, this stepper here, after a print, so if I printed the Voron cube and I returned the gantry to Z10, just like as a home position point, Z10, this one was significantly higher up than the other three, to an extent where the gantry started to bind up. So it was very much out of whack. So I had like the tilted cubes and I had the Z3 stepper being out of sync, more or less. Then I was like, okay, maybe it's the Z belts. So I went in a complete rabbit hole with the Z belts, like making sure they're like perfectly the same tension, exactly the same length, like everything, perfect. Um, didn't help. Didn't help. So yeah, I'm just stepping them on, and then the VHB tape should hold them where they are. And then at some point, oh shit, there's still like there's still some foil. Let me also do like very small cut here. That means we have to redo the other two. But yeah, basically Z3 was drifting, and in some way the A or the B stepper was drifting. That was kind of like the thing we had. And we also we started like again, shout out to Steve and Mr. The DSI and Ravenkeeper as well, like who really helped me troubleshoot this and like hold my hand and supported me emotionally, I would say. Like we started swapping stepper drivers. Maybe the stepper driver's bad, or we also considered swapping the motors. But then eventually, at some point, Steve had the idea maybe it's a clipper issue, and we didn't really like investigate that at first. And then Mr. The DSI found like I showed in the beginning like this like conversation in the clipper support forum, I guess, where somebody described the exact same issue that Prince just leaned or tilted like in one direction over time, very consistent. And yeah, turned out it was just a Clipper software bug that was introduced like a couple of weeks ago, and I was unlucky enough to flash the M8P exactly with one of these bad Clipper versions. So that was quite a thing. Now I missed all the messages. Steve, why are you leaving the film on? I'm leaving the film on because I'm not super fast sometimes. But I think this works out if I just like snap it back on. Yeah, and this is what I mentioned. Like, see here, there's like all these like yellow bits now from the backing tape. That's a bit annoying. Because the backing tape doesn't come off like super clean. There's also like a lot of work to like remove every little bit of yellow. I'm sure if it focuses now here, but yeah, you can see here like this is annoying. So potentially it's something I have to revisit at some point. Let's see if I can reuse this VHB. Should be fine. Maybe not this one. Let me snip the bad corner off. Put it back on. Oh, turns out sticky tape is sticky. Yeah, let me redo this. What slicer? What was the issue? Was it a slicer? So, no, it was Clipper. But yes, we also investigated if it's a slicer issue. Like I printed with Prusa slicer at some point, just to see if it's like this makes any difference. But also no difference, obviously. But yeah, it was really just Clipper in the end. And then the fun part was then I updated Clipper, and the issue was gone. But then the next Clipper bug was introduced. So the input shaper didn't work anymore. And luckily it was like something super stupid. It was just a typo in one of the latest Clipper changes. And I actually made a PR for Clipper, renaming everything to fix the typo. And then the Kevin O'Connor is the Clipper maintainer, I think is his name. He fixed it in a different way, so it's like this close to contributing to Clipper, but then like my PR was not accepted. Got me a headache. Yeah. Mr. The Design, you are not the only one with headaches on the weekends. Trust me on that. So this looks very nice, except for these like little yellow bits around the tape. So this is not nice. Yeah, but let's try if this. I'm a bit concerned now that the VHB tape doesn't hold. It doesn't. But the panel sticks nice. So the VHB tape worked on the other one, so I'm not quite sure. Maybe this needs a bit of time to set. But this is how you take the panel off and put it back on. It's very quick. And it's very, very safe. Like this is actually has quite a snap to it. I did buy the good magnets. Like these are the N52 magnets. So they are good. Has a nice snap. So that's welcome. Looking at my print, that is still printing. So as I mentioned, for the top in the center here, I have one of these latches just to hold it non-magnetically in place in one part. And then for the sides, I mean, it's kind of a bummer now that these don't work, but like it's just like another one of these magnets here, and then it works the same way, basically. Just holding it in place. I wonder why it's a bit odd that the screw is too long there. But yeah, they sit a tiny bit lower, like in the part. Yeah, and then they just bottom out. Like this is exactly like it's like 0.5 millimeter. That's too much. So you need like a M3 by 10 here. Let me quickly check my magic screw storage. Oops, what it has to offer. Just it's a bit chaotic in here. It's not super well sorted. So these are 12s. And I think these are 8s actually. I don't think I have M3 by, yeah, these are 8s. I don't think I have anything in between there. Oh, this is a 10. So there are some 10s in here. Then maybe some 8s got mixed in here. This is a 12. I think something got mixed here. And these should be, yeah, these are 10. So I think we can collect a couple 10s. It's 3, 4, 5, 6. I think we need 10 in total. 7, 8, 9. That's 8, 10. So again, like if you use the standard Voron panel clips, you obviously don't need extra hardware. The kit has enough hardware. It's just like For some reason, this needs M3 by 10s, which obviously is not part of the Voron 2.4 bomb. And that's why it doesn't come with those. But usually if you build like normal panel clips, then you will definitely not need those extra parts. Yeah, I think these are just the right length. So then, Mr. The Design said we need to be quick and snappy with our turn. So that's B. Quick and snappy seem to have worked. But this still does not fully tighten. I wonder why. Like it's not tight. I wonder why that is. I think I feel like this part here is a bit too tall. Like the part that goes into the extrusion is a bit too tall. So the nut basically, that's how it looks to me. Like the T-nut completely bottoms out against them, and it doesn't really tighten apart. Yeah, that's like pointless to be honest, because like it doesn't, like the clip here doesn't even touch the panel. Like there's quite a gap between there. So we can skip over those for sure. And then I think it's just a matter of, yeah, like tweaking the size a bit. It's just a little bit like too tall. Just a bit too tall, and this little lip is on the bottom is too tall. So I think I'll need to work on these a bit. Luckily, it's not hard to reprint them, so that's not too much of a bummer. But I mean, the panel's on, so that definitely is a win. How about we do the back panel? For the side panel on the other side, I still have the 1mm foam. So I would just use the 1mm, and we can quickly put them in. I will have to replace it with the 3mm foam. It's getting heavy. But yeah, the 3mm is definitely better because you have like a lot more space here in between. Pick them out with a tweezer is like someone playing Operation. Well, it's the only way to really pick out those screws, right? No, M8 is too short. Like M8 on these parts, it barely peeks out. I don't have M8 now anymore, but like it barely peeks out. So it's like 0.5 mm that's out. So they're definitely too short. And 12 cm is too long because it bottoms out for these parts. So 10 is the way to go. But yeah, you can see like this is fine and holds. Like the only thing is like in the center. I mean, you can't really see it behind the chat. In the center, like there's a bit of wiggle, but like if you have like another one here, this is really good. And then like it also doesn't like vibrate too much, I think, during the print. And like it's just very handy. I think it's easy to just push from the center out, but then it just comes off, which is nice. So I like magnets. Very nice and efficient. Let's not put this on. It doesn't make sense. I have to change to the 3mm tape anyway. So let's do the backside. And I think the backside is pretty much the same as the other one. So the backside has 1mm tape. Then we can use these thinner brackets here. And so we need, yeah, 3 of them. And we also flip the printer off again. It's getting really heavy. It is getting really heavy. Let me see. So then, mm, for this one, I'm missing screws for some reason. Two M3x8s. Let's see if we can do. No, like even with speed now for these. Yeah, no, it did. Yeah, definitely multiple tens. And here would have been helpful to put a nut on this one. I'm really curious how it will print ABS. Like out of the box now, basically. This one, for example, yeah, definitely does not rotate, even if I do it fast. Yeah, no, it did. Yeah, it's really like multiple attempts. I know, like the T-nuts I used before are were easier. Let's put it like this. Okay, these are already here. This one doesn't want to. Let me help it. Okay. Let's see if I can fix that from here. Okay. Seems to have worked. It's not quite where I want it to be though. Last one. And what I notice here is like you can't really tighten them too much because then like it pulls it in a little bit. So I kind of have to leave them a little bit loose. Okay, so this is the back panel. Let's see. This is this one. Black. Okay, we have to adjust a little bit. Yeah, this one has to be adjusted a bit. Since it's in, this one is not good. Okay. Fits and sits. The only thing we didn't do now is we didn't do any of the corner pieces with the magnets. I think we quickly need to do that. Because the ones I prepared are on the panel already. So these basically go now here and then it should be fine. Let's also quickly try one of these for the center. So this is the thinner variation. So maybe the thinner variation works better. Oh, wrong way around. I think this looks better dimension wise. I mean, yeah, I guess. Oh no. Yeah, it has the same. Like the nut bottoms out. So it basically just tightens the nut against the plastic part here, and then like it doesn't tighten the part itself. So these are not functional, so I will have to mod them a bit. Not quite sure why these don't work as intended, but it is what it is. So then we just do the corners, and I mean, it's not the most difficult part. I mean, if you want to follow that as a guide, just do the center parts. They're exactly the same. And I'm gonna post the updated parts on printables and in my Discord. Cool. Let's quickly do the magnets then. Let me see if I can move this bad boy over. Uh, move that here. The camera knows that we want to work on something that's non-printer related. I have magnets over here. And magnets are fun because they attach to everything. So let's use this as a marker. So the other side needs to go in. Oh, I think we need to see where I put my clamp here. Yep, that's one. Yes, there was. I was like thinking whether I put it in the wrong in the wrong holes. I was the right one. It's the one on the inside. Yeah, well, I'm really looking forward to printing the panels with this machine. So I think kind of like the highlight if the machine like is able to complete the rest of its parts on its own, on its own. Okay. I lost one magnet to somewhere. Here it is. That's three. Really a shame the center parts don't work. Then we could complete the entire thing, but it is what it is. But I think the clips are done in like a couple of minutes, and we can also add the center clips. Okay, that's the four corners. second, I'll move the cable plug in here. And let's not do the same mistake again. And let's peel off the backing. Nice and glossy. It will never look this nice again. Tape. So this is now the 1mm tape. Yeah, just to make sure. Also here it's the same like annoying backing taper, although this one seems to peel a bit better. I can already see fingerprints. Yeah, I think if you build this, like I now already started the other way, but I think it's better to put the foam tape maybe on the frame. Because also in the future, if you want to remove the foam tape, on the frame you can use IPA, like isopropyl alcohol. On the acrylic glass you cannot, because acrylic glass will be damaged. So if you want to remove it at some point, I think it will be easier to remove from the frame than from the acrylic glass. Yeah. Carefully rotate this. And here again, like the backing tape doesn't come fully off. I mean, here it doesn't matter because you don't see it from the other side, so. Not the best setup I have going here with the screws flying all over the place. And looking at the manual, we need to do 2 short runs here on top. So from here, I clipped my nails yesterday, which was a huge mistake. And there it goes to the floor. Let me start in the corner here. Let's actually do it symmetric, just for my mental happiness. So we do it from here. Yeah, the 1mm foam tape, like the backing comes off way better than on the 3mm. From here, which is a shame because like on the 3mm it's way more visible than on the 1mm. Okay. Let's flip that. I feel like this corner doesn't sit very well in. Let's quickly adjust that a tiny bit. Okay, and then let's do the VHP tape with the corners. Working with magnets on desk full of screws. Yes, it's fun. At least you know you won't lose any screws because the magnet will collect all the screws. Okay, let's not do this mistake again, although it's a bit more obvious on the back panel here that there's still like backing on. And I also, you know, like when I decided on the size here of the table, like I thought like, you know, this is big enough, and like I'm already running out of space again. That's a bit annoying. I also feel like I'm dragging one screw around here. Go on. Okay, how about we do it like this? And I think we can also actually just start sticking these on. I'm not sure if VHP types here the best. So my plan is like to try the panels out. If I like the panels, I would go for a bit more like a permanent mounting solution here. So either super glue or some other glue. I also have transparent construction glue, which might be a very good thing to glue these together. The only benefit of the VHP tape here is like it's adjustable in the future. So if I reposition the corners a bit, might be easier. I think when we are already here, let's also mount that exhaust thing. But as with the side panel, like this is it's quite a neat solution, to be honest. I really like it. And then for the back panel, we need to see like, I'm not much sure if we do any of the latches here. So I think what I can do is like to add one on each side, like 1, 2, 3 of these like center clips. I just have to like fix them first. Will also be fun to remove the magnets from here. I guess some heat will help. And maybe I can just do like one each side here just to really secure the back panel in place. So we just have one extra magnet. But like these are really tough to like. You really have to put like quite a bit of force on pulling this off. Also looking at this, I don't think this is really intended to have the VHP tape in between. But yeah, this works fine. Okay. This side we said I will do later because I have to reapply the foam tape. But what we can quickly do, we still have to wait for the print. Oh, we actually can do the top panel, right? The top panel we can do. Yeah, so here I added these like felt glider thingies. I think this is quite a this is something I would recommend, I think, because the corners on the extrusion here is quite sharp, and you will flip the printer a lot, and I think you will damage your table, or you can damage the table. So I just added them here, and then basically this protects the corner here a bit. It's also a bit easier to move the printer around, I guess. So this, I think I would recommend to do. On the other side, you don't need it because you have the Z drives on there. But on the tops, that definitely makes sense. Yeah, then we can also quickly look at this like beautiful construction I did here to like route the bone tube. So it's like 4 zip ties and VHP tape. It worked actually quite well. Yeah. Okay. Um, Side panels, top panel, 1 mm foam and tons of those magnets. Let me see. So there's only one big panel left here, which must be the top panel. I wonder if this one has ever should have ever so slightly different dimensions than the other ones. Is this frosted or is this like no? It's like backing. Okay, let's assemble some more of these corners with the magnets. I'm a little bit sorry because I don't think this is like the most interesting to observe. But we have to get through with this. So we said this one would be the top panel pile. But it's wrong because these are the thick ones. So just to show you, so these are the 3 mm foam and these are the 1 mm foam. So they're just like thinner. So this would then be the side panel, which would mean this one. And it's gone. I just make sure I didn't screw up. So we have 3. These are the center parts. We don't need those. I have 3 corners. There's none here. No, was hiding. It was hiding. So let's do those. Also just like always, I just want to keep the magnets like consistent. Actually, it would be quite cool for the side panels because they're not exactly 1-to-1 aspect ratio. That maybe you can have the magnet orientation in a way that like it tells you if the panel's on the wrong way or the right way. Maybe that would be cool thing. And these N52 magnets are definitely stronger than the cheaper ones. Like you feel the difference, just like from how far it interacts with stuff and like how hard it is to get them off. Oh, ah, that was not enough. But they're quite pricey. Like I think I bought now 100 of these magnets. And they were like 20, 25 euros or something. So it's definitely way pricier than the standard issue 6x3 magnets. I just want to make sure that the panels hold on properly. So that's why I went with the more pricey ones. And you can always recover and reuse them if we don't end up using these magnets panels, but so far I like them. And I can really recommend the trick with the quick release clamp. Like, this speeds up the process quite a bit, I think. It makes it way easier because like otherwise they're so hard to press in. So these are the four for that. We have 4 of the covers here on the one I repaired, so we need to steal 4 from here. Got a couple more magnets. So this is then the orientation. We need to go here. And I think like once you have the technique or like the routine out, it goes quite quick. I think if you do like the magnets on all panels, also in the center as it's intended, it's like 96 magnets in total. So it's quite a few. That's it. 4, 4. And then I wonder if I fix this part, if you actually need the M3x10 or if the M3x12 will work fine. M3x8 we need for these. Let me just zoom you out. I wonder if forward magnets are N52 because I use them on the tab. I am not sure. I'm pretty sure they're not. Oh, wait, I'm trampling on the foam here. So these are the Formbot magnets. Actually, I marked them with like these. You see it here, like the black mark on the side, because all the ones with black on the side are N52. We can do the following. Just check these are the. Let's do a benchmark. I'm fairly certain not, because the N52 are so much more expensive. So it's the same amount of magnets. One Formbot, this N52, and this is Formbot. Let's just see. So I basically have to touch them more or less for this to snap, right? It was really like very close. You see how much further this goes? It's like 5 times the distance basically. Because here it's like really close. No, no, it's actually further. Let me quickly so this is the start line. So this is 1 centimeter guesstimate. And that's around 2, I would say. So they're definitely stronger. But I have the same Formbot magnets on my tap and it works okay. So I think they do the job. They do the job. I also have on this panel here on the back, I have the same, not the same Formbot magnets, but the same-ish magnet style. It works also fine. Like it's not the end of the world. But maybe for tap, it would actually be nice to have the N52 magnets in there. Actually, wonder how difficult it would be to change the magnets on a tap. You would have to disassemble quite a bit. Okay, this is one. So your trick definitely works, Mr. DDSI. Like if you turn faster, it seems to rotate the nut. More or less reliable. Still takes a couple of attempts. There we go. Yeah. And this one, for example, absolutely does not want to rotate. This one works fine. Let's help this guy a little. And then only the doors are left. Then we have all the panels installed. With some little omissions here and there, but also magnets don't like heat, so at ABS chamber temp they are quite loose. Oh, okay. Well then maybe that's a good option to have the N52 there and just like take as much as you can get. But I don't think the bomb says something about them having to be N52. Okay. Here we go. Okay. Then that's foam tape. On the floor. But they give you plenty of foam tape, so that's at least quite good. Okay. One. Let me just rotate the panel. That's easier than rotating the printer. I think this one is, yeah, exactly. This one is completely square. If I would have been smart, I would have rotated it clockwise. It would have been a bit easier to cut the end, I think, because then we are like on the open side basically. So now we have this overlap here. See, now I have a little gap. Let's rotate this direction. Okay, here we go. Let's flip it over. And to be honest, I don't expect to take the top panel off that often, so I will just not bother with the VHB tape here at all. And to be honest, they sit nicer. Like the corner here is nicer without the VHB tape, because I think the VHB tape is not really accounted for in these parts. Also like this, like it's relatively quick to take off if you would have fingernails. Maybe without VHB tape is even better. Although it's also nice to, just do it like this. Both works. But we did not. They are like, they're really like strong. Like it's actually quite tough to get them off. That's a VHB tape. Let's be consistent. Takes like 0.5 seconds. Let me quickly cut our little corners. And that's still the VHP tape that came with the kit. So, what do you guys use to clean your printer panels? Because the IPA is a no-go. So I usually use just like kitchen soap, and that works kind of okay. Oh, Mr. Digita, I missed your message. The only problem is the stronger the magnets, the harder tap hit the plate. That's true. Um, but I think there's a setting in Clipper to randomize the position for the center probe. And the probing for other prints, it's always in a different spot. So I don't think it will be like overuse your bed too much, to be honest. And you know, a plate is like, you can always replace a plate. Like worst, if push comes to shove, you can replace that. If I remember back, like when I had the ender as an ender, like how many holes I burned into the bed. Just like with stupid stuff. I don't even know how I managed to do that. But I managed to do that quite a lot. Yeah, maybe if you want to like permanently fix these corners, maybe some glue is better than tape because tape it's like a millimeter of thickness, of course. Whereas the glue maybe would not. Same stuff. I cleaned the bathroom mirror at the no idea if it's an international thing, but called GIF Universal here. I didn't damage the panel so far at least. Okay, so it's like the glass cleaner. I don't know, like I feel like they also have some stuff in there. I just don't know like chemically what the acrylic plates like what damages them actually. But I heard that Steve is using the same GIF to clean the bed. That seemingly works great. Okay, so here's the magnets are stronger than the tape. Also that comes off easy. 1, 2, 3. This one I do later, as I said. Um, let's quickly do the doors, I guess, right? Doors, magnets. I see magnets. +1 for the glass cleaner, I see. Okay. Let me sip a bit of water. It looks like slowly like a printer, you know? Comes together. So, you know what would have been smart? Like doing the Hotend before the panels, but only smart people would have done that. But it's very easy to take off the panels, so good for us. Okay, let's check the door. So these parts, let me quickly check what we have left. So these are the 4 corners for the side we didn't do yet. The center parts I have to revisit anyways. So that is yeah, not a huge bummer. They're quick to print, so easy enough. Let me just put all of them back to the printer part box. And then let's also quickly check here for the door parts. So I have the door hinges. Let me get you a little bit closer. So I have the door hinges, which we should have 4 of. Or are there 6 there? 6 of them. This looks like a door. This looks like a door. There's another door part. This looks like a door. This looks like a door. So we have 5 hinges so far. We have 4 of these corners, which we should have 4 of. This is definitely not a door part. This looks like the door part. This looks like something completely else. Wait, let me just check. How many hinges are there? 6, yeah, so we missed 1 hinge. Ah, here. It is hiding. And of these magnet parts, of the latches, we have 2. So I also... Ah, here, 2. Everything is there. No. I'm so impressed you printed all these parts on Voron Zero. So many parts. Yeah, it's quite a thing. Not sure if I showed it before, but like this is how I organized that. So these are the panel parts. These are a bit messed up, so some parts are duplicate. Because I added these like thicker panel parts. But yeah, you see here like it's 3 gantry, 5 tab, 7 Nevermore. These are all the 2.4 files. Yeah, safe. And I really just organized them like this, and then every time I print a plate, I just add the, I mean, here I didn't do it, but I printed that. I add the little lock symbol, and then I know I printed that. And if I need a part twice or 3 times or 4 times, it will be like 4 times on these plates. If you discard. See here, like, yeah, and then I just walk my way through. So in the beginning, basically, I just make like all these Orca files, and they are on the Discord. So if you want to print all the parts, and you have a V0, go for it. Even if you don't have a V0, if you print each of these plates, and I mean, you can reorder them, of course. And like if you have 2.4, you can print like all of these parts in one go, of course. But if you print all of these plates, you have all the parts for 2.4. So your electronics, like these are, I mean, these I printed on the Switchwire. These I printed in PLA on the Switchwire. It's for the Clipper screen. I must admit, I printed in PLA, but they will work out. Yeah, it's just like organization, I guess. And then it's actually quite okay because like each print takes like, I don't know, somewhere between like an hour and 3 hours, usually for these plates. And then just I did it like in the days I work from home or on the weekend, you know, like every like hour or two, like you just take the plate off, pop it back in, it does its thing again. Like it's not a big deal. Like it's just like a smoking break, basically. Some people do smoking breaks. I do 3D printing change plates breaks. um, there's IPA in it, so might damage some types of plastic acrylic, I guess. Yeah. I don't know who posted that in the Discord. I think it was Neo or somebody who had like all these like micro cracks in the acrylic glass from using IPA. So it's definitely it's a thing. It's definitely a thing. Panels. So we have magnets. We are experienced with magnets, I would say. For the doors, let's just use the Formbot magnets that we still have. I think it's nice if they're not too tight. And then what Alex suggested, like most likely I will go with the click-clack doors anyways. We should have 8 magnets. We have exactly 8 magnets left, so it's like they counted. For the first one, doesn't really matter. And they suggest adding super glue, but I think I'm not sure if this is really required because also here they are quite stiff. I think we are fine without. We can add a tiny bit of glue on the side here. Yeah, but like the Voron parts, like it's way easier to press the magnets in compared to the parts of these magnetic panels. But yeah, something like this comes in really handy, like some flat aluminum, metal, whatever. These don't like each other. Yeah, like you really feel these magnets being weaker. Okay, so this one means this one needs to go this way. Yeah, the press in wait, like I can do it really easy by hand. For the panel clips, like you really need the quick release clamp I used there. Also here, I don't see them coming out, to be honest. So I don't think I'm gonna add glue here. If I will have issues in the future, it's quick to add a dab of glue. And just always, like, you see I do it, like I always snap it to one part. I know it's the right orientation, and then I press it in the next one. So then I know I always have to make it the right orientation. Pure APIs, no. Are those Amazon or Ali magnets? Would like to some strong ones. These are from Amazon. I mean, I can give you the link to Amazon and L. It's at N52 and it is N52. So, or it feels stronger than non-N52. That's the thing, like with these magnets, like there's no way to tell, right? Like it's like, how do you know that they really are what you get? Like I was also a bit concerned, but like they feel stronger, so I'm positive they are. But it's like, how do you want to know? I'm also not sure if there's like N52 is like a standard or something. I don't think there's really like a way to like know if they lie to you or not. Uh, so they do tons of VHB tape now. So let's just also do tons of VHB tape. Let me quickly get the cutting board from my kitchen. 1 second. Yep, even better. I actually have a cutting mat. So let me see that. Move that a little bit. Cool. Okay. So then, what are we gonna do? Just make sure I get right. But yeah, here they're a little bit like. I mean, it could also be my print. I see there's a little bit of elephant foots here on these. So this might be why they're a little bit sticky. Yeah, so that they don't rotate super nicely for me. I mean, it's fine. They functionally work, but let's see if this grooves in a bit. But then, yeah, maybe clicky clacky doors would be like a nice upgrade. No, it can't be the elephant's foot. Yeah, just a little bit like, yeah, not super freely rotating. Actually, there's a little bit of like gunk on there, so let's just remove that. And then I just put VHB tape on the whole thing. And in a second, we will just cut it out. Yeah, see here, like the VHB tape sticks to itself a bit. I already noticed that like it sticks to the surface it's lying on a bit. And I think now we're at the segment where this is the case. I guess that's also where the difference to like original 3N VHB comes in a bit. Because like, now it starts being a little bit problematic here. Like it peels off the backing tape on itself. Which is not quite ideal. Okay, so I generously cut it out. So let me just quickly make sure it is all like nice pressed in. And then we can just take a knife. I think it's even best to just do it on the corner here. And it's just like nice and shape you want. Yeah. That's it. Nope. Okay. I feel like there's more VHP type stuff here. Yes. These are a bit more tricky to cut. So the VHP tape is just like too slim for this. Yeah, let's just do it in the more wasteful orientation. Hi there, Michael. Then let me see how we do this. I think the only way really is to cut it on the part itself. Which should be fine. Let me quickly check how does that come together. So these are sitting on the panel. So we just need to make sure they are not sticking out here. Yeah. Like a X-Acto knife would be definitely the better choice for this. But believe it or not, I don't have one. So I use the tools. Oops. It's really easy to cut into the part here. And there we go. You made it 2.4. Congratulations. How's it working? Are you happy with it? Was it worth the effort? So then let's also quickly do the M3 and the T-nuts. M38. We need 6 of these. You get your kit next week. Oh, very nice. Also the Formbot kit, or did you go for something else? Oh, you made the you made the live. Oh, welcome. There we go. Fill this in here. One, two, four. We might have cut this here. Maybe I have to remove a tiny bit of the VHB here on the inside. So now notice that it's preventing the rotation a bit. And not on this one. So this one is a bit problematic. Maybe I pushed the tape a little bit too far in. Let's quickly check all of them. This one also seems fine. 1, 2, 3, 4. This one is missing. Okay, this seems okay. That seems also okay. Also okay. This one is a bit of a problem. Let me just remove a tiny bit on the inside here. This one is fine. This one is fine. Okay, so then they're all fine. Okay, that's all the VHP tape. I got the Seabor R2. Oh, nice. I think it's also a very good kit. I was between both of them, to be honest. In the end, I went with the Formbot because I like the main board more. I don't remember what the Seabor has, but this one has the M8P, which was like my favorite, or like my top choice. So I went with this one. Had to add some more magnet handles to the middle to the door. They were sagging hard during high-speed travel infill. Night and day difference. Send me a link on the Discord. But yeah, I'll just build it now like as intended, and then we can see later on how that is turning out. Okay. Now let me think. So let me just quickly remove one side of the backing tape. So this will be the outside. So I will glue all the things to the front now here. I think this should be like on the edge. So I will tape this on the edge. Let me do top and bottom first, and then for the center, I think it's smart if we do some measure stuff first. Just, you know, would hate if we put it together and then like it's not center. Nope. No, don't stick yet. Shit. Nah. I think I have to redo this one. Second attempt. So once they're down, they're down. You can't change them anymore. Lesson learned. So I just need to be very careful to align them properly before touching. Okay, so we need something that we can use to measure. So this is 45.5. Advanced math will tell us that 22.5 is the center of that. So we should be roughly here. Roughly there. In lack of something better, I'll just take a tiny bit of VHB tape, just as a little mark, like where this goes. Okay, and then we set the last one. We have to redo. Yeah, this is shit. Like, so here the edges basically are connecting to the layer below. It's not good. I mean, so far we didn't have any problems with this tape, so I'm not complaining too much. I also have a Prusa Core 1, which should be here in the next 2 weeks. Oh wow, we are really like went on a shopping spree with printers. I'm curious what your impression of the Prusa Core 1 is, because I think it's like also a very nice machine. I mean, I don't have one, but let's just say if I would have been on the look for a printer before I got my first Voron, this might have tempted me quite hard. And most likely would have ended up being my go-to instead of the V0. Here we go. Looks good to me. Let's do these. So these go this way here. Maybe it's smarter to glue those on the machine, because then maybe we can use these a little bit to align it a bit more. Let's first install the doors. Let's put one of them up there. Actually, both of them up there. Get rid of this one. And we have 3 T-nuts, which are my favorites, so that will be fun. Not quite sure if it's smarter to put it on the back. Can we put it on the back? Yeah, there's nothing on the back. We can put it on the back. We don't have the filter yet, so it's easy enough to put it here. Oop, that was too fast for my camera. Here we go. I had these like color markings here and I lost them, so I always have to check which screwdriver is what. Super annoying. Okay, success. Because these one I cannot rotate manually, like they have to. They're a tiny bit higher. Just a hair. Okay, let's also do that. Didn't pay attention, but something tells me it's M3/8 and the T-nut. Raj, did you already print your parts for 2.4? Or like, will you print them on the Prusa Core 1? That would be, I think, a really cool test of the machine. So this should, does this face up or down? This faces down as I have it. Perfect. Now we can also use the door to determine center. So a bit. Now like hanging here a bit, so maybe we have to move that a hair up again. Not a fan of this, but it hangs up and down, so it hangs on both sides. Yeah. It's literally the bottom of the magnet. Stands out like the tiniest bit. It's just like here, the bottom of the magnet, and this is where it like catches just a bit. So I think maybe I use a little file to just like file off the top of the magnet there. Let's try first as it is. I'm printing them at the moment on the X1C. I'm not sure if that's allowed. Does it not work? No, it did work. I mean, technically, I mean they work. It's just like they feel a little bit like it's not a smooth motion from the printed part. So, but the VHB tape holds fine. That's actually more my concern. But we didn't put foam on these panels, right? No, there's no foam. No foam involved. Okay, then let's glue those center parts here. Exactly. Now the magnet helps us to align them a little bit. Glad not doing the only. I won't tell if you don't. I got you. Yeah, it's fine. No, I think like it's very common that people have like X1 and then just want something more customizable. Yeah, I think this works fine. Like then, oh, now they also don't go all the way. Ah, they should go all the way down. Okay, let's see in a second. Oh, that's the wrong one. This one. Let's quickly try this one. Here we go. Yeah, also the door overlaps a little bit in the center. Let's see. I think we need to do some slight adjustments here and there. Let's start with this one. Yeah. It's a bit it hangs just in a couple of spots. I think like I'll kind of just use the file and like fix it up a bit. So the doors just need to be a little bit like more out, but I don't think there's something I can adjust here. Okay, I can't really push them. They are just where they are. This one moved a tiny bit. Let's see if I can. The bottom now works okay, but here it hangs a bit. See? Yeah, it's literally. Let me see. I can't quite see where it's. Oh, now it hangs on this part here. So I think this needs to be a tiny bit more in. Yeah. I guess you have to close the uniform. Yeah, it's not a nice source. So I think that is will be upgraded at some point. I mean, the thing's like you can't have too big of a gap in the middle. So I feel like this is like really tight. And I think still like they hang on the magnet here. Like this is primarily where they hang. Like you can actually see like a little mark here now on the panel. Let me do the following. Just really taking the edge off. I feel like these should have a chamfer. If these doors would have a chamfer, it would be much better. It's a bit better, but you know, like if the door would have a chamfer here, ah, I lost my VHP here, and a chamfer here, like it would close much better. Like I mean, then it's like more difficult to manufacture, of course, but this would be like the premium solution, I guess here. Mine is exactly the same, yeah. I think it's just like the tolerances are so small on these doors that like, yeah. It's on my update list. This is straight to the update list because this will, yeah, it doesn't feel premium. I don't know who said that in the chat, but like somebody said it doesn't feel premium, and this is exactly that. Like it functionally works. Well, it's a bit of a struggle. Yeah, you have to really like close them in parallel here. Then they fit perfectly. If you close one before the other, they collide with each other. Cool. So except for this one, we're done with panels. So at the moment, we don't have the filter here yet. Let's quickly install it. But I'm also considering maybe we do that next time when we do the skirts, because there's a fan in here and we have two fans on the skirt. Then we can do all the fans in one go. Yeah, let's do that. So I will leave this open for now. When I print ABS, I'll just put a little bit of painter's tape over that. just that it's closed. Um, well then, basically, except for this panel, which is here, and I just missed the parts, and I have to redo the foam tape. That's it. I guess it's not for the door. You buy 2.4. Nope. It's not for the door. But it looks nice. Like, if this would be working smoother, I think they shouldn't have went with the printed hinges here. That would already help a lot, and then just add like a bit more tolerance to that entire thing. Maybe if you could adjust the door hinges like a little bit out, would be better. I'm trying to figure out where exactly it contacts. Yeah, it's still on the magnet here. Let me take a bit more off here. Oh, good. Ah, no, I scratched the. No, I scratched my frame. Not too bad. Yeah, it's a bit better. Yeah, it's really just the magnet here. They should have positioned the magnet further inwards. And then it would work fine. Here, like the panel still connects with this this part here. There we go. No, it's quite good. Close. With the better magnets, it would close by itself. Yeah, it's still like a bit here. Good enough. Yeah, it's serviceable now. Okay. Hotend. That's what's left to do. If you do it a little bit more with a bit more force, it works. It's fine. This is functional. Okay. Quick service break. So this should be good enough for ABS now. I'm quite happy. Like the doors are straight. Like everything lines up well. It's just like there's a little bit of like it's what catches there on the corner. I feel like if you have like a chamfer here on this part, it would already be solving like a lot. Okay, but I'll stop now because I added the second scratch now. So it's Let's not do that. Okay, hold on. So, I quickly showed in the beginning. So we are going to upgrade to this Triangle Labs TZ E3 V2 2.0 easy TZ E3 2.0. It has a V6 mount basically, but the heatsink is a bit different. Also has the Ender 3 mounting holes. But yeah, this is the one that is on printables. It kind of also grabs the heatsink here on the bottom, so it's actually quite a stable fit. So what we need to do is we need to add two heat set inserts here. We don't need to do two here for the ADXL. And then it's just quickly crimping a cable, and this should be more or less drop-in replacement. The thermistor changes, so this is one NO4 and T thermistor. At the moment we have the PT1000, so we need to change the configuration a bit. But it should not be like a big deal. Let me quickly grab my soldering iron. And yeah, it's just 204. Oh, we also forgot the latches for the panels. We forgot the latches for the panels. But to be honest, I'm not sure if I need them. I want to print with this as is, just with the four corners. Um, just to see how it acts. And then I either go for more magnets or for the latches, one of the two. So let's start this. So just to know to talk about when I say latches. So these are these latches. This one is for 3mm, so it doesn't fit on the side panel. It's very simple also with the T-nut, same mounting. I just use black screws here for aesthetic reasons. And then basically you can open them like this. So this is like the other option. I also linked them in the Discord. These are very strong. These are not like there's the one latches with the filament hinge, but I didn't like the filament hinge. They felt really weak. These have screw hinges and they feel way better. Let me quickly fix my music. There you go. Okay. But yeah, let me first figure out the Magnum mid panels. The right door is bending at the top. 1 second. Let me heat set insert, and then we check the right door at the top. The right door is bending at the top. Oh yeah. Yeah. There's oh no, this is how far it goes. I mentioned I did this 8-hour print job, right? And I added this little camera mount here for my camera. And now the door was like bending over that. Totally forgot. Let me remove that. There you go. Yeah, I was a bit scared. I had to go, I had to leave. So I added like a camera just to observe a little bit what's going on. In case of disaster, I can stop it. Okay, so with this thermistor cable, I think you need to be super cautious. It looks very thin. So just make sure it's like on the bottom here. And oh, not work. Just make sure these are like can move freely here. I'll quickly keep that like this. We can recycle the screws basically we have in there at the moment. So let me think. So firstly, we now have the doors, which is a bit of an awkward thing. That's why I mentioned like maybe we would have been smarter to do this first. I mean, the panels are easy to remove. The doors are not. You had to break one of those thermistor wires. Knock on wood. Yeah, but I mean, I think they're quite stiff. Where do you hang? They look quite stiff. So I think they're quite strong, or stronger than you think, but still, like they're so thin. Oops, maybe a bit much. I can do it. I can do it. You got a bit of a top view here, but I really find it difficult to align the camera with this big printer. There are the 65 and 80 watt heaters for those hot ends too, if you need more power. Yeah, like I wonder because like. So firstly, I wanted to go with the 40 because I don't have one of these hot ends. I bought multiple for reasons. So I feared that like having more wattage really adds up on the PSU side. So 40 watt it is. Now I'm also not sure how much more actually power you get out of that, to be honest. Because I think what mostly increases the flow is the melt zone length, and that doesn't increase, I think, with the higher wattages. And 80 is just overkill, to be honest. And that's the nice thing about the stealth burner. I really like it just comes off. And very easy to maintain. Okay, so we need to remove the feel. So I can't see. I like that the panels are like golden. I don't feel the latch. There should be like a latch to hold it in. Wait, I have to see. Yeah, I did it right. It just doesn't feel like that wants to come out. Okay, can't really press the latch in. Like there's this latch that holds the cable in. I can't really press it in. This is a bit odd. Maybe that's the end of our Hotend upgrade. Cannot unplug old Hotend. Okay, here we go. That is one stubborn cable. One stubborn cable. Yeah, a little bit where I am with some. I have 60 watt on mine, and flow testing it goes up to 9% duty cycle before it can't melt delay. Well, like the problem on my mini 340 watt couldn't keep up with. Well, 60 watt has zero issues, so definitely help a little bit. But all my 60 watt plus heaters jump 2, 3 all the time while tuning. No? Okay. Limit you, I think. Well, let's try it out. They're not super expensive. I just like, I'm not quite sure why I ordered 3 immediately. I should have ordered like 1 to test out and then see how that goes. But I went with 3 immediately, which, yeah. I also unplugged the tap now accidentally. Okay, let's plug it in a second when we do all the cabling. So this is the old one. This is the new one. They're pretty much identical from a mounting perspective, you can see here. So I also just transfer the Bowden tube. I'm pretty sure that's the same length. Oh, I think the heatsink insert is not super straight. Okay, this screw struggles a bit with going in. No, it's fine. Okay, whatever. That was weird. Yeah, that feels good. Yeah, as you can see, like it's really similar setup. There's really not much that changes. And comes also with a couple of like replacement nozzles and everything. So I think it's quite a sweet kit. And like this one was like 20 euros, so it was dirt cheap. If the bone wants to come out, I would reuse the bone. Here we go. I think this is way too long. Yeah, exactly. We have to, yeah. Then let me leave that here. We cut a fresh piece. We cut a fresh piece of Bowden for this one. Does the 6 watt fluctuate to and never settles? Only when I set 150 when tapping with Eddy, which I'm testing with 2 and 230 is not a problem. So found that you can set M140 versus M19 macro for that. Decent hardness for the price. Yeah, I mean, from what I hear, yes. I will try it out for myself. Let me get my bag of bone. And I'm just cutting like a super overlong piece. Just make sure this is all the way in. And now let me mark 11 millimeters. Just quickly make sorry for being out of frame. I'm just doing this, so just making a small cut at 11. And then let me just quickly. No, I lost my cut. Here it is. This doesn't have to be super straight. I mean, it should be quite straight, but it doesn't have to be like super straight. And I always use this countersink thing tool here to make the top, like the edges a little bit less sharp. It makes it easier to push in the filament. Should push this all the way down, and then this should be it. So let's put this back. So the thermistor is definitely, oh yeah, we need to recrimp the thermistor. I totally forgot that. We need to recrimp that to the smaller plug. Okay, so we don't need that anymore. These parts I don't need anymore. This one we don't need anymore. This we don't need anymore. We only need this. Oh yeah, we need this comes with this extension cord, which is like way too long. We also need to crimp. Oh, 1 second. Yes, I'm still annoyed. Like, I mean, now it's at least like 2 centimeters with the panels, but it's just ever so slightly too tall. So, let me see if I can slide this heat shrink a little bit down, and then I would just cut it like here, something like this, and like you can something like here. Then we need the pH, and we need tweezers for this one for sure. I mean, Steve was making fun of me for using tweezers to get out my screws, but for this one I definitely need tweezers. So no discussion around that. Add ballistic tag. Yeah, I touched it. Never sure. Yeah, this one I need to crimp with the smaller setting. I never get, I never remember that. That's one. No, shit. I don't have a good crimping mojo today. Luckily, we don't have to crimp a lot. Okay, get a fresh one. Okay, that's these two. Not a question of questions. I don't think I have this connector in here. No, doesn't seem like it. I have three. Ah, yeah, here. Have you looked into getting super chats turned on? I'm not quite sure if I can. Well, also didn't look at it, to be honest. I can check it out. It's actually not the worst idea. I mean, I'm not sure if a lot of people want to use it, but at least, you know, give the option. Oh, this one? Yeah, this does not feel solid. Just want to say. Okay, let's start over quickly. Let's do them tiny bit shorter. I think I damaged the cable there. Crimping is easy. No, it's never. Especially like these, what is it, JST XT, like the small ones. It depends a lot on the cable for me. Like some cables are easier to crimp than others. Like I really like silicone cables because like they're so easy to crimp. Yeah, I just crimped off the top. So this cable is definitely not in the easy category. And we are getting awfully short now. So if I use the small setting, I damaged the cable now twice, so I don't think I can use the smallest setting. So we have to stick with the medium setting. But the medium setting is not the most tight fit. So let's just be very careful with this. just give this like a... Yeah, see here, like now it's coming off. Okay, this cable is officially awful to crimp. Slowly but surely running out of cable. That's not a good crimp. So the cable just breaks on me, basically, when I crimp it. This seems to be okay. Okay. Can I rescue this one? Not worth the effort. Let me grab a fresh one. Let's just be a bit gentle with this cable. No, did I crimp the wrong one? Wait, is pH the small one or... Oh shit. Ah! I crimped the wrong one. Okay, so now the cable starts getting... That also explains why I crimped off the cable with the small crimp setting. Well, if we continue like this, we have to extend the wire. I'm using the medium setting. I can already tell you this is not tight enough. Okay, this seems okay. Okay. Yeah, this one is off again. Fuck. This is impossible to crimp. Like basically, like if I crimp it on a medium setting, it just falls off, and then on a small setting, it crimps through the wires. Sensor not easy. It's not about the sensor, it's about the cable. The cable is shit. The cable is shit. That's my main problem. Uh, let's do the following. Let's cut them a little bit shorter. Let's solder a different wire on that, and I crimp the other wire. Because this is not going anywhere. So let's just cut them like this long. One shorter, one longer. Like I usually don't struggle to crimp these connectors that much. I mean, sometimes I do, but usually I don't. Um, Let me see. And I said I like silicone cable. So let's just use a little bit of white silicone cable for this. Plus they're easy to crimp. It's just like, let me quickly test crimp one of these connectors on that. Because this one is a 24 gauge, which is quite thick for these small connectors. Yeah, that works. That is a good connection. Let me actually just use this cable. I don't think it needs to be super long. Let's just crimp a second one. I use usually different size for insulator versus conductor, bigger for the conductor, then I squeeze with the pliers to help it fit in the housing. Yeah. It's also, like I usually just like hold it, squeeze it a bit with these pliers just to have it in place, and then I go at it with the crimping pliers. Oh, I need. Also not a cable that really wants to be soldered. Like the soldering tin doesn't really stick to it. Let's see. So let's use this one for the shorter cable. And maybe before we do that, let's get a little bit of heat shrink. Feel like I had white heat shrink. Fine. Just gonna push it on top here. Then later we can cover both with one. Okay, right. Didn't want to make this like a big soldering operation, but Does not really want to. Next, next is Wago clamps. Yeah, this works. Okay. Then where's the other one? Let me quickly check lengthwise. So this needs to be yay long. Here we go. This was harder than it had to be. Uh, Gotta go coach a couple CrossFit class. I didn't know you were a CrossFit coach. Enjoy. You can do the same for heater. For the heater, I think I'll just use the extension cord. I don't like soldering heater wires because they have like higher like amperages. So yeah, I don't like soldering those. Let's see, this is a bit difficult now because the cable is way more flexible. It's the downside of the silicone wires. It's always a bit hard to push them in the housings because you can't really push on the cable. This is like especially. Here we go. Oh, it did not a good job measuring the cable length. Like this one is significantly shorter. Well, it is what it is. I'm not going to change it now. Hope that curves the right way. Okay, heater wire. So this should be fine. Like this is not ideal, but we should be able to hide that. To be honest, I think this connector I don't trust. Like this doesn't really like. So I think you are winning this one, Mr. The Design. Because like this is like more soldering. Yes, I like that. That's not how I thought this would go. It's also soldered more or less in the same spot here somewhere. Will be easier to crimp. Yeah, might also be the case. Okay. Um. Oh, I did not cut it in different lengths. Let's shorten this here. Healthy amount that we are certain they can't connect. I'm trying to have the solder connection a little bit longer here, that ideally we have a little bit less resistance. Getting toasty. Yeah. Now we have like a nice long connection. That is what I like. Let's do the second one. Okay. But now I want to be done with soldering. Will be max 2 amps. Yeah, exactly. It's still like 2 amps is 2 amps. Let me see if we did a good Yeah, so we did quite a good job like separating here. Maybe we could have had a little bit more distance, but it should be fine. Did I have... Ah, here. I was like, where's the rest of the white? We have to be AFK for a bit. Oh no. Let's hope you don't miss the first print in ABS. Yes. Okay. Let's do a quick test fit just to see like if the wire length is okay or no. This was not in properly. Now it's in. Okay, let me quickly clean up the mess here a little bit. I have a bit more space. You know, if we would have been smart, we would have soldered the wire of the other hot end onto this one. Then we wouldn't have needed to crimp the other side. Here you go. So, hot end. So the thermistor wire is fine. We can move it over here. That's good. And the hot end wire, I just want to quickly check roughly lengthwise. Where we should end up. Something like this. Let me quickly cut those. So this is the length we want. Let me quickly see. So I think somewhere in here. So we're looking for this connector. I think I see it already. This is not. This is. And then for the configuration, I don't think we need to change too much. We need to do a very quick pit auto tune. We need to change the thermistor. And besides that, it should be fine. This ended up a bit crooked. Let's see. I kind of want to recrimp this one, but it's already a bit shorter. Let me quickly. One more attempt. This is, by the way, the microfit connector is exactly what the scrimping pliers are actually for. I use it for everything, but it's Molex microfit. Just twist these a bit together. Oh, that's all right. Did I? No. No, should fit. Comment the max chip and enable the TH sensor type and GPO in the config. Yeah, exactly. That's what we need to do. I think we also need to change the. No, we actually don't have to change the jumper on the board, right? Is this the right one? Yeah, it's the right connector. This is also the right connector. Why? Why no fit? I'm very certain this is the connector. Yeah, it's JST. Oh, this one is shit. Ah. I don't know what this one is then. Well, if we continue like this, we have to solder again. Let me use the center setting again. Yeah, perfect. Ah, success. Wow, this was harder than we expected. Uh, Mr. Design, do you think we have to change the little switches on the board? I don't think so, right? They're only for the PT1000. Like if we don't use it. Oh, CAN cable, yeah. Might be that these are for the CAN cable. Let me first plug the tab back in. Otherwise, we will forget. Which will make for a very bad homing experience. Here we go. Now it's back. It's a very hidden little spot there. And this connector. Perfect. Okay. Cable's long enough. Would have been really awkward if the cable would now be too short. Squeeze all the cables. That's the wrong one. A bit difficult to organize all the cables now here. Because the cable for the thermistor falls exactly where the screw is. Let's push it all a bit around. Here we go. Be careful with the connector. I once had it that the connector was like not seated properly. I had the short, which was not very fun. Now look at the wire scratch against the cable cover. Which wires? Which cable cover? I can't follow you right now. Which the thermistor cables scratch against the cable cover. That's fine, right? Now it's all sorted. It's not the most ergonomic position to screw in screws. Okay. And I think we are ready. I think we are ready. Man, this is such a chaotic corner over there. Okay, I guess. Here goes nothing. 3, 2, 1. Red LEDs there, so we didn't kill something yet. There's not much space between the thermistor plug to the cover. No, there's not, but this one is already a modded one. You can see that the panel here, you see? Like on the standard one, the black part here has the same thickness all around. And here you can see it gets thinner. So this is the modded one already for the EBB 2209. On the switch wire, I have the standard one where the black... Oh, the fan turned on because the thermistor is not configured. I was a bit confused why the fan now turned on. It most likely measures like a very absurd temperature right now because it's the configured for the PT1000. Let me... Right. Claire. Yeah, exactly. It's not happy. It's not happy. Cannot update MCU config as it's shut down. Did I press the wrong restart? I mean, should freak out because of the thermistor. Exactly. Something like this. That's what I expected. So we need this all to go. EVB 2209. Manual. But we want this one. Right. let's go EVB 22.9 config. Let's just look for the sample config. This one. Yeah, something like this looks okay. So it's like the standard sensor. I will check on mine, but I got the functional printed parts from Formbot, so I'm not quite sure. And I moved to G to Eno. Ah, nice. Get the config out from Git. Yeah, that's what I did. Oh, but I did not. I copied too much. This one is called EVB for me. Now it's happy. Extruder is 2023, 22. Let's quickly heat that to 30. Yeah, it responds. Oh, you don't see it. Sorry. So it all looks fine and well. And that means let's just quickly do the pit calibrate. Heater is extruder and target. Let's do 240. So this can do its pit. Oh shit. Let me do one thing. I quickly want to emergency stop that. Just to interrupt the pit autotune. Do we want to print ABS? I'm not quite sure how long the bed will take to heat up. Let's go for it. So I just wanted to heat the bed up, that like the bed heats up while we do the pit. Still need NT 104 for sensor type. Temp will not be okay. The temp looks fine to me. This should be the correct one, right? Because this is also the 104F. Yeah, it should be fine. Yeah, I think this is fine. It looks fine. Also, the temperature was 100% spot on, like the 23 degrees is what I have here. Oh, it also did the pit altitude? No. I'm very quick for the pit. Okay. To be honest, I would just print more or less the same that we printed last time. Let's just do like our Voron cube in empty. They're like quick and fast to print, so I like that. It's a very good test. So let's do 0 top shot layers and 0. And that will be then the noble full ABSX. So we just use the marble white. Yeah, the only thing is like it will not be fully enclosed now. So shall we print ABS? But the problem is now the bed is already at like 1,000,000 degrees. Yeah. Okay, but ABS it is. Okay, that is one panel. We got one of the corners here. Two panel. Three panel. Problem is the 4 panel. So this one will be will be quick fix. Oh, it also doesn't hold. Okay, then I know what to do. So we need to pit this in a second. I just want to make sure that the bed is like already heated. The sticker. Yeah, but the you mean this sticker here? Ah, wait. $104 and T4. But this is what I have configured, right? Here. I mean, tell me what value you expect there. This is a 104 NT. So you expect this one here. Yeah, 104F. And what do I have? NT4. Oh, so you expect this value here. 104 NT4. I mean, let's use that. I'm not sure what it does. Different. Let's see. Yeah, but this is wrong. Oh, wait, it was heated. Now I don't know if this was right or wrong. Because now I don't have the baseline temperature. Oh, wait, you don't see it, sorry. So now it says 37. Let's just do another pit auto tune. And while this is pit auto tuning, let me do my quick fix panel. So my deers, basically, we quickly mount these two bottom corners, and then I use the latch on top. And then we should be able to like mount the panel for a very short print. And then at some point I can change the foam, and then we can properly install it. Also preheat the bed since you restart Clipper. I already put it in. I put the 110 back. Okay. Oh, but like I'm really looking forward to peeling off that foam tape from this panel. That will be super fun. Yeah, see, in these two, they are not turning again. And don't ask me why. Okay, good enough. Then, so this is this latch I showed before. So I'm just going to add this in the top. And then we should be able to just temporary mount this on the side. It's not super stable, but good enough. Okay, then the badge is at 110. We need to quickly add these calibration values to our config. Where are... Oh, they are... oh, wait. Actually, let me quickly say. No, I can't do it. I was like trying if I move the values here that it can save it, but it can't. So we have to quickly do it manually. That's... I don't know, like, why Clipper can't do that. If it's like multiple files, basically, for people who don't know, if you split your config over multiple files and the extruder is not defined in the main printer config, then it can't automatically save these values. You missed my comment about need for an exhaust fan with the Nevermore. The Nevermore is not configured yet, so it will not be active. That is not yet done. So for now, we will enjoy the fumes, and by we I mean me. Let it quickly quad gantry level. But then why put the exhaust fan in the end? Well, it's part of the kit, so I will just install it. Then it's still like a question if it's on or off. But I would just install it because it's part of the kit. But let's do that exhaust fan next time, basically, when we do the other fans as well. Bit concerned about that bone tube flopping in around there. Here we go. Okay, let me quickly... get them out of the back. And yes, there's a massive hole in the back now, but for now it's fine. Let me quickly feed. Yeah. Feed filament in here. And the bone tube is also a bit fixed. So, okay. Already getting toasty inside there. Let me quickly... let me give you a different angle on the entire thing. Yeah, most likely for mine it will also end up being an exhaust cover at the end. I just want to build the kit as intended for the beginning. I kind of diverted now with the panels, but I guess everyone is capable of installing the normal Voron panels by themselves. And Hotend is now changed. It's so much quieter already. As although there are still like massive gaps in the enclosure. You need to redo quad gantry level points as you're running tap and config setup for the Why was that? Why would I have an run, Steve? You mean here in the main... here? You mean this? Yeah, already that was still my to-do list a bit, because these points are a bit weird for me because it's 225. I think this should be 250 here for these two. But it should still calculate fine, because you give it the points and the gantry corners. So it should still figure it out. But yeah, these could be 250, 250, and 250, 250. That's what you mean, Steve, right? Yeah. But I assume that's 250, right? For you. 250, 250. But yeah, it should still calculate correct because like it has the gantry corners. It's just like the distance between it does the probes is a bit less, so maybe it's a little bit less accurate or something. But it would not. Oops. Oh, there was something. um, Max temp. Let's just put that to 285. So I basically put it on the max temperature and then like it tripped when it like overshot a tiny bit. Oh yeah, oops. I want my bed at 110, please. You can go 25 millimeter. Yeah, I'll change it later. That's a good remark. It's made for inductive probe to not probe at the edge of the bed. Ah, okay. That's just, change it quickly. I just kept the values. I always saw the values are odd. I just did not question too much. Like it was on my list to check, but here we go. So it's always 25 from the edge. I'm not gonna restart now. Like I really don't think this does much with the tap accuracy. The bed heats really quick though. I have to say, like this bed heats quicker than the V0 bed. I mean V0 is DC. This one is AC, of course, but like it heats blazingly fast. The question now is, will my my probe calibrate might be off a little bit now because the nozzle is longer. I'm not quite sure on tap if that influences if the nozzle is changed. I think it should not. I'm not quite sure. Oh shit, now I'm confusing it too much. I wanted to check the extruder, but now I'm doing something else. It cools down quite quickly. Shit. We feel? Yeah, like chamber already gets quite warm. Doesn't matter. I was just thinking because you had to configure in the beginning the Z offset, right, of the tap. And I think that's the distance, how much the tap carriage needs to move to trigger. So I think, yeah, it should be independent of the nozzle. Oh, and I increased the speeds quite a bit for the quad gantry level and for probing. Because I figured like it doesn't really matter how fast it does the XY movement, and it's quite a big printer. So if you speed up those moves, it saves quite a bit of time on these processes. Okay, so then I don't gonna do the thing now, but then let's do what I initially planned. So let's heat that back up. So that was kind of like a because what I want to do is I want to extrude like a bit of filament. 210. 250. Yeah, we can send that. Yes, it pulls the filament in. I can see it. Yay! We are melting plastic. Then I would say let's send that. Upload and print. Only thing is now we have filament oozing out of our nozzle, which will not help with tap. Let me quickly. We don't have a nozzle brush yet. That's also on the to-do list. I am a nozzle brush at the moment. Yeah, I don't know, like these hinges, they're always like crackling, making crackling sounds, like when you open and close them. So I'm not a huge fan. But yeah, they're functional for now. Secondly, you should also do a shaper calibrate because the Hotend changed, which will change the mass distribution on the tool head. To be honest, the print start you use with not with plastic, so as long as you print and retract, shouldn't have clean out. Yeah, I actually like I had no issues at all now. Like the nozzle was completely clean the entire time. The only time I had a problem was when the print was canceled for whatever reason. Oh, there was at one time there was a CAN communication issue, and then like the printer shut down, and then it was oozing a bit, and then next time it had issues. But yeah, besides that, really not a deal. But yeah, I still prefer having a nozzle, just like a nozzle brush, just to make it more reliable that you don't have to like worry and like don't have to babysit. It's very silent. Like I'm really like it's enclosed, of course, but like you don't hear anything. The part cooling fan is not running yet, but still. Yes, it also depends on the filament. It's also true, and the temperature, right? Like if you I know like push PLA like to the maximum, and you need it to be like super like liquid, and you increase the temperature, and it will also ooze more. Um, I guess we all know PETG being the pain it is with oozing. We are printing ABS. Oh wait, I also have. I didn't build any macros yet. Like it's really like bare bone as far as it gets. Um, oh, sorry, I touched HMI. So right now it's pushing. I think I limited the filament at 12 millimeters per second at the moment in the slicer. That's still like quite a speedy print, I would say. Tap is working. Also confirmed. Tap is working. You can go 20 to 25 with Hotend. Yeah, I need to. No, sorry. Figuring it out. Also on the V0, I have it at 12. Don't ask me why I limit that at 12 at the moment. I was just checking now because I had the V6 before, so I was checking these filaments. Yeah, the other ABS I have at 15. So I think my ABS I had always a tad lower. Yeah, all my ABS are around that. For PLA, I go like 25 to 30. Need to. I'll do like max flow test on this one. 270. That's quite hot. Like I at this ABS I printed 260. The Form Futura ABS I printed 245. It's relatively cold. I think it really depends on the filament a bit. But yeah, I'm also like for ABS parts, I'm not super concerned about speed. Like I rather have them proper. I know that like the faster you print ABS, the more you get warping issues, for example, because filament has like less time to settle in. So yeah. If I can print reliably, like a big plate of ABS on this machine, I don't care if it's like slower or faster, to be honest. So far, this looks pretty good. It's a matter of max flow versus latitude. Yeah, exactly. If I get more reliable parts, and if I print a little bit slower, I don't care. Layer time cooling in Orca. I think I don't have that. Do I have that? You mean the I do have the fan dynamic based on layer time, but the fan is between 20 and 75%. So the moment should more be. Fan is 75% at the moment. It will show speed and flow. Yeah, at the moment I'm actually not even speed limited. Like you can in mainsail it goes around 8 millimeters cube per second. So the flow is not limiting at the moment. I'm also not pushing the speed too much. I also still have the steppers at like 0.8 ampere. So first fans. First fans. Like speed tuning is like down the road. I first want to have the machine working, be reliable, pooping out good prints. But this looks like it can now print its own parts. I would say, like it looks good. So I can print the skirts, which will be fun. I think the skirts will be like the biggest ABS parts I printed. Most likely. I can't think of something as big because like I was always limited by the V0 because I never printed like ABS on the switch wire because it was a bit painful. Um, so the skirts will be the biggest ABS parts I ever printed, I think. Yeah, it also slows down a lot for overhangs. Like I use the default profile. It really slows down for overhangs. You can see it now, like in the Voron logo. That's also like most likely we get away with a bit less. It's just like trying out and seeing what happens. Actually, it looks pretty good. When you print skirts, your fan failed. Oh shit. I actually don't have a replacement fan at hand at the moment, so I hope it does not. Yeah, this looks like a success to me. It's really silent. That's really good. I take a silent, slower, reliable machine over like a super fast machine, to be honest. It's definitely success. Fair point. I mean, it's straight, so hey, it's something. Yeah, like some Z layers are a little bit inconsistent sometimes. Something I still have to look into. Like generally, it prints really good, but sometimes it's like you see um on the right side next to the Voron cutout, like you see like two lines basically coming in when the light goes over it, and that's seemingly like a little bit of inconsistent Z. Championships, yeah, like all stuff down the line, step by step. First we finish the skirts and everything. Yeah, we screwed up two layers there. So on both sides, you can see it. Hey, stuff like that comes before the chamber sensor. I also would like to have a sensor like in the electronics bay, just like the ambient electronics bay temperature. That would be kind of interesting, I think, as well. Yeah, like to be honest, like I'm not sure if I need more clips on the panels like that. I don't hear any rattling. I don't hear any sound. Those four corner pieces might have just done it, to be honest. I mean, this side definitely needs work, obviously. But I think don't fix what's not broken. Potentially, I just leave it really like with the four corner. Here's a magnet I'll probably push in. It's like small things I need to look at this like again like tomorrow. Yeah, it's like I think like the slowdown for overhangs is definitely a bit of overdone. Uh, does it look like a shift in layer or extrusion issue? It's hard to say right now, to be honest. actually might be a tiny layer shift to the back. Need to see like when the cube is out, but actually. Yeah, like look from the like if you look from it at the sides, I don't think I can show you right now, but then it's like a little layer shift actually. I think I'm pushing it with the travel moves at the moment. Because the travel moves, I was thinking about that when I had the long print, so it's actually quite a gamble. Um, the travel moves I'm doing at the moment at 12,000 acceleration and 650 speed. And I think that's very close to the maximum at what the motors can do at the moment with the current amperage. So I think that is a risky business. I should most likely reduce that travel speed to like 500 and like 10k acceleration, just to have like some headroom. Acceleration is more important than speed. You mean for the skipping or for the print? Yeah, it will not say it's 0.8. I just, like I want to have some airflow first over the stepper drivers, of course, before I like push the amperage a bit up. For the overall print time, yeah, I mean it also depends a bit on the object, right? Because like if you have a large printer, and let's say like you have relatively high acceleration, you have a large printer, you will reach the top speed relatively quick, but then you also are limited by the top speed in a certain sense. So it really depends on the print as well, right? But yeah, I'm not tuning for speed yet. Like I really don't care. I just want a reliable machine first. Good prints, reliable, and then like I can, if I feel like, do speed. But let's see about that. It's actually for me like the noise is more important than speed. If I would need to pick anything, then like I'd rather have a silent machine that takes an hour longer. I also will add like the machine will stand over here in the corner. I will add like a rubber mat basically where the machine stands on just to isolate the noise a bit more. I did that with the switch wire as well, and like really reduced the sound a lot. Just because like not the entire like cabinet resonates with the machine. Yeah, but besides these like this slight layer shifter at the beginning, like it now works fine. Also, my time broke 25 acceleration printing Droid infill. What do you mean your time broke? The one thing I tried actually was like pushing Z speed a bit, and that's also like not the smartest idea. um, oh, the tap broke. Oh shit. Like the printer part broke. Because what I was trying to push with was like that speed, and then like one motor stalled out, and the others were like still pulling, and then like a entire gantry basically went like that. So that's risky business. Oh, it's belt temp area. Yeah, okay. You can replace it, but maybe that's then where the CNC tab comes in at some point. Post a picture on Discord. I would be interested to see like how it failed. But yeah, also like from my switch wire, I had like the tool head mount fail twice, I think. Um, that's also why I switched to the CNC tool head mount on the switch wire. Just I don't have the water anymore then, and I know it will not break. I'm a bit annoyed about the small layer shift there. I'm pretty sure it's a travel move. Can't imagine what else it could be. Especially with the chamber temperature rising, I assume the motor performance will not get better. I would expect maybe be a bit worse, so maybe it's just like it's now too much. But also like this layer shift doesn't line up with any like anything on the cube. 650 at 24 volt is a bit pushing it at ABS chamber temp. Yeah, exactly. I think that's the difference because like before, like I did yesterday the 8-hour print with these like speeds and settings, and it was fine. Like I didn't have a single layer shift in 8 hours. So yeah, most likely might be just not a chamber temp. Post a picture in Discord. I'll check it after the stream. Let's see. It should be done also in 2 minutes, it says. I mean, overall, the cube looks good. I was out of focus, I'm sorry. Overall, the cube looks pretty good. It's just like the layer shift, like at the bottom of the Voron logo. I really like to say this marble ABS. Like, it looks so good. I actually want to get like another spool, just like to print stuff for around the house. So it's the end of the Voron logo, and now it should be like quite quick to finish up the cube. 1 minute left. Yeah, but so far the Hotend seems to work great. Like it doesn't have any problems pushing the material at this speed. Also, like the temperature is like super stable for me. Like fluctuates plus minus 0.5 degrees, I think. So that's pretty good. 40 seconds. Inner, outer, inner is not ideal for overhangs. No, it's not. But I feel like the print quality overall looks a lot better. So, and it really depends a bit also like on your layer height and stuff like that, and like how steep the overhang is. So for me, inner, outer, inner, it works pretty well actually. Here we go. Hot. Ah, give me my cube. Here we go. That might be a bit close. Can I zoom out? Here we go. So, I mean, overall looks good. This is a layer shift. You can see it like it's very, very minimal, but like you see it's a layer shift. Like it shifts here and here. And we have here a bit of extrusion issue. Obviously, we didn't modify now the pressure advance, so this can cause issues. And it's here and here, like on both sides. And we also didn't do the shape calibrate. So I think I'll just run through like the standard tuning steps. And I would expect like these things to go away. Like this really looks like a shaper issue, potentially. Um, Pressure advance seems to be okay-ish. But yeah, I'll just run through the tests again. But hey, this is a ABS cube of the 2.4. So I would call this a success. Like it's way better than last time. Still like a small effect, but yeah, I can't have it all, I guess. Well, pretty good minus layer shift. Yeah, that's also like what I would say. And the layer shift, like I'm fairly certain that it's really just uh, yeah. I'm pretty sure it's just like the travel speed being too high. So this is like quite a good outcome from my side, I would say. Also, the panels are all on, so that's good. And the magnetic panels work great. So I'll just swap out the foam on this one to finish that one off. And then I would say this is like a success. So yeah, I think I would leave it at that for today. Um, and we see each other next week with skirts. I hope I get everything printed over the weekend and next week. Did the panel shake when printing? No, not at all. Nothing. Like it's super fine. Like I didn't hear anything shake or rattle or anything. Like it was very quiet. Um, so that is all great. Like I really I'm not even sure if I will add the centerpieces of the magnets, to be honest. I'll just most likely leave it. You missed the middle support? Which middle support? I'm not aware of any middle support I missed. Yeah, for the panels, the middle support is missing. Yeah, I know. Because it didn't work, right? So I missed the middle support, but like it's not shaking or anything. So I'm not sure if it's really. That's why you asked. Yeah, exactly. But like it works really well. Like I'm not sure if I will add it actually. I mean, I might just not. Let's just see. I'll print a bit with it and see how it behaves, and if I encounter problems, I add them. But potentially, I just leave them. Cool. Okay. See you next week. Enjoy weekend, and as always, happy printing.